So now that we can simplify rational expressions, our next question is, well, what else can we do with them? And we think back to everything that we've learned to operate with as far as fractions, and the next thing that we learned to do was to be able to add and subtract. And I know I'm not hooking you in right now. Fractions is like the biggest F word in math. And I picked this up from one of the math help websites that I offer to you guys. The author of the website said everything you hated about adding fractions, you're going to hate worse with rational expressions. But the positive is, once you get a little bit of a flow on it, get some practice in, you're going to do just fine. And this is why I say that. You already know how to do this. Your 5th grade teacher taught you how to add fractions, and in most cases, the more interesting ones, you needed a common denominator. You couldn't add, say, for instance, the 6 and the 4 together here in the denominator. So we're going to be looking at expressions that look something like this, and following that same pattern, we recognize that the denominator isn't the same. 7b to the 4th, 3b squared. We just need a slightly different method to be able to figure out what the LCM is. So this list of directions looks pretty hairy in terms of adding or subtracting rational expressions when they have the same denominator. Once we know they have the same denominator, remember when we subtract polynomials, it's the same as adding the opposite. So we're going to follow that pattern. We're going to put parentheses around the second polynomial. We're going to distribute through the negative sign. So basically we're changing every sign of the second polynomial and then combining these fractions into one by combining the expressions on the top, combining like terms, and writing the common denominator as our one denominator. Following that, we can go ahead and simplify, and we'll also talk about restrictions on variables. So let's look at a couple of examples. Three over x plus 2 over x plus 2. I can see that I have a like denominator of x plus 2. I'm going to combine the numerators, 3 plus 2. That's going to give me 5 over my one denominator, 5 over x plus 2. And there's nothing I can do to simplify that. Another example, 5n plus 2n. Okay, so now I'm combining like terms. Right? It's the distributive property, 5 plus 2 times n, that's 7n over n plus 1. Remember from yesterday that I can't take this n that's in a term and try and cancel it with an n that's a factor on the other side of the fraction bar. This is as simple as this one can get. Okay, now I can see that I have 4 minus 5 over t minus 2. I didn't go through the details of changing the sign here because I think 4 minus 5 is the way most of us think through these. A few more examples then that all have like denominators. Now here I can see a situation where we're subtracting. So let's make that happen. 7b minus 2 minus b plus 7, and then the denominator 3b plus 6. So 7b minus 2 minus b minus 7 over 3b plus 6. Now let's combine our like terms. 7b minus 1b, that's 6b. Negative 2 minus 7, that's minus 9. So now I look at these expressions and I say, can I simplify these any farther? 6b minus 9, well, that's got a common denominator of 3. 6 is 2 times 3. And then 9 divided by 3, that's going to give me 3. In the denominator, I can factor out a 3 with b plus 2. 3 divided by 3 is 1. So I have 2b minus 3 over b plus 2. All right, now I'm thinking, where does b plus 2 equal 0? the denominator has a value of 0 when b equals -2. So I need to restrict that value from the denominator. So this expression simplifies to 2b minus 3 over b plus 2, and I say that b cannot be equal to -2. Let's work through another one. Maybe you pause the video, try and work this one out on your own, then check your answer. Don't forget, you're distributing a negative sign, so a negative times a negative is a positive. 2c minus 3c, that's negative 1c. 1 and 4 makes 5. Okay, so I can't simplify the numerator and denominator. There's no common factor that I can factor out, nothing in the numerator and denominator that I can divide through. And then I'm just asking myself, well, where does 5m plus 2 equal 0? Well, that happens when m is -2/5. So m cannot be equal to -2/5. So these problems, these exercises, when we're working through them, there's two pieces to the solution. The first is how the problem simplifies. The second is restrictions on the domain. Okay, one more quickly. 4a plus 8a over 9b squared. So 4 plus 8 is 12a over 9b squared. And pretty clearly, b is not allowed to be 0. So the more interesting problems happen when we have unlike denominators. We need a least common multiple. And we remember back to adding and subtracting fractions, our middle school teacher probably had us make a list of multiples. And we looked for the smallest number that was in all the lists, and that was our LCM. We're going to do a similar type thing to another way that you learned how to do LCMs. We also learned how to figure LCMs of larger numbers by taking factors. Every factor that appeared even once was going to be part of the least common multiple. So we're going to do the same kind of thing with expressions. We're going to factor out the polynomials, list the factors of all the polynomials, then take all the common factors, and that will be our LCM. Alright, so if this was just 9 and 6, the least common multiple of 9 and 6, we'd go 9, 18, 27, 36, 45, and so forth, 6, 12, 18, 24, 30, and we'd see that 18 was our least common multiple. So 18, it had a 2 here and 2 copies of a 3 here. 9 times 2 made 18. Similar type thing is going to happen here. We have 2 copies of 3. We have 1 copy of 2. We have a 2x minus 1 and x plus 2. So 3 times 3 times 2 is 18 times 2x minus 1 times x plus 2. That would be our least common multiple of these two expressions. Let's do another one. These need to be factored. My GCF, 5, y squared minus 16, which is 5, y plus 4, y minus 4. Over here, I've got a trinomial. 2 factors of 12 that add up to 7. So x plus 3, x plus 4. So here's an x plus 4, I'm sorry, y plus 4. that's repeated. So I know y plus 4 is going to be part of my GCF. Y plus 3. Here's a y minus 4. So I've got the y plus 4, y minus 4, y plus 3, and the 5. That expression would be our GCF. All right, so if we're going to add or subtract polynomials, they have unlike denominators. Here's our steps. First thing we're going to do is factor out the denominators, because we need to follow this pattern of being able to list all the factors that are going to appear in our LCD. Then we can rewrite each fraction with that new common denominator. Then we can multiply each fraction times the factors that are needed to reach the common denominator. Then we can add across the numerators. So let's take a look at how that might look on some relatively simple examples and then some tougher ones. So 7b plus 4, 3b squared. We talked about this a little bit earlier. I have a 7, I have a 3, we'll put this off as side work. I have a b to the 4th and a b squared. So the least common multiple here is going to be 7 times 3, 21, b to the 4th. So I'm going to convert both of these fractions to a new denominator that is 21b to the 4th. 21b to the 4th. All right. So I had 7, I got to 21. I need to start with 3 there. I need to multiply by a 3. I already had a b to the 4th. So the only thing that was missing from my first denominator in my LCD was 3. So 9 over 21b to the 4th. Here, I needed to start with a 2. I need to multiply by 7, because 3 times 7 is 21, and b squared. Alright, so now I have 14b squared plus 9, no common factors there, or 21b to the 4th. Nothing here can be simplified, and clearly b cannot be equal to 0. Okay, let's look at another one. I have 25x, and I have 100, which is 25 times 4. So my LCM is going to have a 25, an x, and a 4. That's 100x. All right. 25, to get to 100x, I need to multiply by 4. So I need to multiply my numerator by 4. Here, 100 to get to 100x, I need to multiply by x, and by x here. So 16 minus 49x over 100x. Again, there's no common factor here that can be factored out of all three of these, so we leave it the way it is. Let's skip on ahead to one that's a little bit more challenging. Taking a look at example number 7. 2d plus 1, 4d plus 2. 2 times d plus 1. So my LCM is already 4d plus 2. I need to multiply this expression times 2. 2d minus 6 plus d minus 1 was already in my LCM.